RavenDB now includes the time series model in its latest version. Look into the future with time series data. Uncover patterns, find detailed information for forecasting and analysis, create charts to visualize your data to make the best business decisions with the most precise information. The unprecedented amounts of data going through time series analysis demands that your database handle indexes skillfully. They must have an automatic option and be able to be made on the fly to keep up performance. RavenDB is up to the task, saving you time, complexity, and money, especially on the cloud. Today, RavenDB CEO Oren Eini takes you on a tour of the flagship feature for RavenDB 5.0. You will discover monitoring your time series data with RavenDB, reading high-level and deep-level details about a time series stamp in a RavenDB document, querying data to detect emerging patterns, creating charts with RavenDB time series, and more. Feel free to ask questions by clicking the Q&A button at the bottom of your screen, and Oren will be happy to answer them at the end of the session. Enjoy your presentation, and here's Oren.
Hi, thank you for showing up for this webinar. I'm going to talk about a big feature for RavenDB 5.0. This feature is time series. Now, when we talk about time series data, we have to understand what we're actually talking about. Because let's see some examples. In time series data, we typically don't really care about a single value. We care a lot more about the set of values as they change over time. And heart rate monitor, you don't care what my current heart rate is 78. And now, that's meaningless on its own. But if you know that, okay, my average heart rate is X, that is something that matters. And if you see, oh, your average heart rate is increasing on a year-by-year basis, maybe you need to go out and get some exercise. Same things if you think about storing GPS locations. Having a single GPS location is okay. Having a set of GPS locations gives you a lot more detailed information and it's kind of scary. Other example is measuring speed over time. Okay, are you driving safe or driving safe, stuff like that. Temperatures and currency exchange and stuff like that. The interesting thing about those type of data is that we tend to get a lot of them. And by a lot of them, I mean that we may very well end up with tens of thousands or millions of data points for single time series. For example, if I'm tracking my heart rate over a period of a few years, it's very easy to end up with millions of data points. If you're tracking the server stats, CPU and memory over time, and you're capturing that every 2 seconds or every 5 seconds, and you have a history of 2 years, that adds up a lot quicker than you might think. So now I want to look at that. We have 2 separate scenarios that we have to deal with. One of them is that we have a lot of independent time series, and one of them we have a lot of data in time series. Let me try to explain what I mean by that. If you have lots of independent time series, a good example might be if you want to track the CPU statistics per server over time. Okay, what happens if you have 10,000 servers? What happens if you're tracking IoT devices that report something like, oh, this is the humidity in this particular point in time, and you just deploy 500,000 of them. That's what I mean when I'm talking about lots of time series. Lots of data in a time series is when you have something that either reports a lot of data. For example, I may have some sensor that give me information at every 10 milliseconds. I need to record some data. Or you have data that you have to keep track of for a very long amount of time. Again, heart rate data is a good example, specifically because I have this data and I'm going to show it to you. But other example might be if I'm going and looking at a Microsoft stock price, and I want to see the changes in price over time. And I do that in granularity of every offer ever made in the stock market for Microsoft stock, and they have something like 40 years of history. That adds up to a lot of details, and we need to figure out how to do that. More importantly, RavenDB is a documents database. How does it work when you want to store time series data inside of a document database? We can absolutely store the data directly inside a document. I mean, that's easy. Go here, data. Let's say that this is heart rate. 01, 01. Something like that. That would work. That will also be horrendously inefficient. Why is that? That would be horrendously inefficient because what happens if I have 30 million of them? Or in this case, 33.9 thousand data points. At this point, if I'm looking at this is going to be a very, very fat document, and that's going to be unpleasant to work with. It also means that I'm going to have to deal with a lot of documents like this. Every time that I want to record a value, I have to open this document, throw it in here, and save it, and it gets really nasty. We don't want to do that. Now, let's talk about some of the things that we have to look at. Here are a few examples of time series data. Here you have something very simple. For every server, we have a particular point in time and the CPU utilization. Makes sense? In this case, we have multiple values that are stored for each particular date. And that's interesting. So let's see how it works. In RavenDB, I'm able to store in a document multiple time series. We can actually see it here. Here are time series. This is RavenDB 5.0. I'm running the beta edition. And what you can see here is that in addition to attachment and counters, we have here these time series. And this particular user has a heart rate, and we have about 36,000 entries for his heart rate over time. And that's really interesting. Notice that other users have different sets of data. And now, like here, for each server, I'm going to have a time series with the CPU utilization. So the first thing that we need to understand is that a time series in RavenDB is always scoped to a document. What this means in turn, it means that if you want to track stuff that are for a particular entity, you typically track that inside that entity itself. So you're not going to have a heart rate time series that bring you data from multiple users. For each user, you're going to have their own heart rate series. The other thing that we have to take into account, let's look at here. Here's a particular server, and here is a particular time entry. We can see that here is the CPU utilization, and this is the amount of memory that was used on the machine at that time frame. So a particular time series is not limited to a single value. Let's look at that in here. And pressure. Now we have multiple values for this particular time series. Now let's look at this in details. This is a timestamp. A timestamp is a single entry that happened at a particular time frame that I care about. The values that we actually have are double position floats, doubles basically, and you can store here from 1 to 32 values. Seems simple. I do want to pay I do want you to pay close attention to the tag. What is this tag? The tag is something about the tag tells me something about the timestamp. In this case, what this tag tells me is that this measurement was taken using a Fitbit. Let's add another measurement. And now we have it. So all the way down. Here it is. So this is taken by the Apple Watch. That's the only way that we can add additional information except for the values. And it seems like this would be an incredibly limiting system, because how can I figure out how this works? Well, as it turns out, we can do something really nice. Let's see, let's say, I have no idea if these numbers are correct or not, but they serve for a good example. So think about that. Now we have modeling based on this. Okay, and now I have a place to stick all of the meta information about a particular timestamp. And that's important. And we see exactly why in a little bit. Now, what you've seen so far is me showing you some raw data. It's not really that interesting. Let's see what happens when I want to query. And you can see here, these two queries are exactly identical. And first, we select which user or employee we're going to run, and then we apply some projection. So let's do that in the reward. Users, series. And now I'm saying, okay, give me the heart rate. And I can see it here. And you can see that this covers about 1 day or half a day. And the heart rate is all over the place. I'm using heart rate because it's a good example of, oh, I don't really care if the value is 67 or 75 at a particular point in time. Looking at the aggregate information is really interesting on the other hand. I can also say, you know what, that's too much data. Let's copy it on so go back. Let's copy it to a much smaller value. Now we're looking at values on a per minute basis. And we can start looking at that at more and more granularity, etc., etc. You can see that we have a total of 12 hours in which that was the max heart rate of this person. Other things that we can start doing, we can start doing this. And now, notice what we're doing here. We are saying, okay, now we're able to do additional filtering on the data based on the associated document. So that's really cool. It has performance implications that we'll talk about later, but for now, you can see how I can treat the data. You can also slice and dice it. You can see that the date range is from 2 a.m. to 1 p.m. So let's close the data a little bit. Now we're looking at now we are slicing the data to a narrow degree. And now I want to do it on a 1 minute interval. And again, see the data, work with it, do interesting stuff with that. Something interesting to point out, all of the data that we use is UTC. So this is UTC. I can also do something like this. And shift the data a bit based on my timeline so I can see where it's at. Okay, so notice that this and this are exactly the same. We actually, the RQL provider is actually going to turn this into this automatically. Remember that it's going to be important in just a little bit. Before that, I want to talk about the client API. So here is a typical way you can work with the client API. You go to the session, you ask, give me a time series for a document ID and the name of the time series, and then you just decide what to do that. In here, I'm saying, okay, let's append data to the time series, and then I'm calling save changes. As usual with RavenDB, everything is transactional. You can have document creation, time series creation, counters, attachment, all of that as a single unified transaction. You also have support for bulk insert. So a good example is here. I'm creating a user, opening a time series for this user, and then just appending on that. So that's interesting. This is a lot more interesting. So I'm saying, okay, give me all of the users who are over 21. Get the heart rate time series, only where the watches is Fitbit, group it by 1 month, and get you the average and max in that particular time frame. There is also an option here to specify the date range, obviously, but it's very close to what we already seen in the raw queries here. Basically, the syntax is almost identical. Here is a slightly more complex query. Here, time series in this date range. Load the watch, make sure that the manufacturer is either one of those. Group by 1 month, and here you can see that we have a strongly typed API and the usual thing as usual. It's really not that interesting. It's meant to be very obvious and in your face in order to make sure that you know how to do this properly. Now, remember that I told you that when we have a time series RavenDB translated into this, we translate it into this sort of thing because now we're able to process the result on the server side. So in this case, I'm saying, okay, if I'm looking at this employee, should I worry? And I'm basically saying, okay, let's look at your heart rate on a 1 hour range. And if the max is too high, then that means that I do have something to worry about and maybe act upon. This dystopian query is more interesting because of the capabilities it shows. It shows you how you can do really interesting things on the server side. For example, you can apply this multiple times and compare between 2 different time series from the same document or from different documents. And that can be a really interesting capability for you to work with. Because, for example, you might want to say, okay, what's the difference between today and yesterday in terms of the amount of work that was done on an hourly basis, and how this is trivial to do. Something really, really important. Notice here, we're always queried on a single time series, which leads to an interesting question. If I have multiple time series and I want to query across them, the classic example might be, okay, I want to find the maximum heart rate that I need to look at. So look at that. You can't do that as a query. You can do that as an index. And that's actually something really important because it means that you can index time series data. Now, the problem with indexing time series data is that you typically don't want to do that. Again, let's go here. I have 6.2 thousand values here. And if I'm going to show something else, this is my heart rate data, and I have 5 years of data and 11.7 million entries to work with. Now, the idea here is that I don't typically want to look at each individual timestamp entry. I want to look at them globally. So here's what I'm doing. I'm saying, okay, let's index the time series. I'm getting a list of entries, and I will get into exactly why it works in display later, getting a certain range of entries. And then I'm saying, okay, let's group them all by their date and document ID, and let's output the number of entries and the maximum heart rate that I have to deal with. That's great. I can add a reduce section. This reduce section is going to tell me, okay, now let's aggregate for maybe for multiple ranges on the same date, and let's aggregate them again by date and the user, and let's get the maximum heart rate that I have. What this means in turn is that this is a standard RavenDB index. If I want to query on that, I can. And let's see that as an example. Here I have max. And max, it's not really that interesting, but you can see here that I'm querying over the entire dataset. Now, just to give you some idea, the dataset here includes 1 billion values. 1 billion values. And I'm able to query over that in 1 millisecond. And I will touch exactly on how this works later on. Okay, we have a question from Giresh. I think I'm pronouncing that properly. Do you have any use cases for how RavenDB works with sparse time series spanning longer time ranges, but with a larger amount of documents? I'm not sure what you mean sparse time series. If you want to have an entry per day or per month, go ahead. There's no issue with that. Everything will just work. And you can easily have as many time series as you want across as many documents as you want. So let's say that I'm looking here at the sample data. And what I want to have here is daily cells over time. So each one of the employees is going to have, at a maximum, 1,000 entries, 10,000 entries if they've been working for this company for the whole life. But he may have, 10,000 employees or 100,000 employees, each one of them with some metrics there. And everything will just work easily and seamlessly for you. It's not something that you don't have to worry about high degree of a cohesion between the values. Okay. Mircea is asking, and again, I'm hoping that I'm pronouncing it properly, how can we delete all time series data when we no longer need it? You do it like this. RavenDB has support for automatic rollup policies. And I'm sorry, the time series feature is still in beta, so I can't show you the user interface because we haven't built that piece yet. But I can show you the API to do that. And in this case, we are defining a policy for the users collection. We're saying that in this case, let's say that we have a heart rate and we want to say, okay, keep the data for 6 hours. That's it. However, we also have the roll-up data. So every hour, we're going to roll up the data from the raw results and we're going to roll that into 1 hour increments. And then we're going to keep that for 48 hours. And then on a daily basis for 1 month, monthly basis for 1 year, etc. Stuff like that. The idea here is that RavenDB is going to take care of everything for you. Downsampling the data, all sorts of stuff like that. We actually don't really do downsampling. What we're doing, we're going to take, what is it? We're going to look at the data here, and based on the range that we specify the policy for, we're going to keep min, max, first, last, sum, and count for each range that you wanted. So let's say for every 2 hours. I think that's the, so this is first, last, min, max, sum and count. And for sum and count, we can compute the average as well. Now, notice that in this case, we have quite a few values that we can look at. We can play with that, but that's just, visualization for you. The idea here is that we are effectively taking the results of this query. In this case, we're going to say do it on an hourly basis and storing that. And then we have this query. And this is a really interesting query because it may span longer than the raw policy specified. In which case, we're going to transparently look at the roll-up data. So in this case, I'm going to say, I'm going to, for the first 6 hours, I'm going to look and do the computation directly. And then I'm going to go to the hourly time series, which was generated by RavenDB, and use that value. And then for the daily, which case I'm obviously unable to show you the information on an hourly basis, but I will show you that on midnight of that particular date. We have a question from Jose. Philosophy is related to documents and time series related to events that happened in the past. RavenDB intends to guarantee the immutability of these documents. The answer is no, and this actually leads us to a set limitation of time series. Let me explain. Typically, with Raven, I'm able to do something like this and create a snapshot, a revision of the data. A snapshot is great, but the one thing that it's not going to snapshot is the time series. And why is that? The fault lies in this document, which has 11 million entries. And the fault lies in documents like this, that has tens of thousands of stuff like that. The problem with revisions and time series is that we need to store quite a lot of information in order to make sure that the revisions work properly. No, this one. Here we go. Now, the downside of that, we are not able to keep revisions properly. It also leads us to another observation. RavenDB is a multi-master database. And this is applicable as well. What do you remember that? It means that let's try to assume that we have multiple nodes where you can write the time series to. Then at some point you reconnect and you start sending the data from one to the other. And at that point, you end up with, oh, even if you thought it was mutable, it's not really. And it's not really because of, at this point, you're stuck with data that was immutable, that was mutated on another thing, etc. So time series are not immutable. They're not subject to revision, sadly. But they do allow you to do some really interesting things, and we see it in just a little bit. Okay, Mircea is asking, how can we estimate the storage requirement? Say for the example that he showed, what size is the time series data? Okay, so let's look at this. Here we have about 1,000 users. Each one of them has some amount of a few tens of thousands of records. Let's go and look at the data itself. Sorry. Data file, tables, and here you go. You can see that in this case, it doesn't take that much. However, if you go to the time series, the TS database, and I remind you that the TS database is this guy, which has 11.7 million entries. And we're going to look here. The size is 50 megabytes. Now, I'm going to go into a lot more details about the internal structures, how it works, but the more predictable your data is, the better it is. So data such as, oh, I now have heart rate that doesn't change very much, is very good for us. If you have GPS coordinates and they are always changing, and the position is very accurate, so we have to keep lots of bits around, then that gets more expensive. If we go and look at this database, here we have 4,000 documents, and each one of them has, let's see, something else. I had another one that some of them has tens of thousands. Okay. This one has quite a lot more. And if you look at the data itself, you can see that the data is not really that interesting. But notice the position. In this case, we need to look here. No, sorry, I'm looking at the index. Now we can see that it takes a lot more. The storage requirements that you want to look at is how predictable the data is, and we do a really good job of doing nice compression of the data. Okay, Jiresh again, can you demonstrate how we deploy multiple stereo for a given set of documents? For example, if I wanted to see how heart rate and blood pressure correlated to one another. Okay, let's do that. Let's take this guy. Heart rate, let's say 68. Let's create another one. Okay, so it's not really that interesting an example, but Now you have something like this. If we look at the raw data, you can see here the raw values. It's not really useful for me in this form, right? So let's change things. Let's say, okay, goodbye 1 hour and select max in by 1 hour. That's going to be interesting to look at the data. Minimum. Now, I'm now able to do this. Function. Heart rate, blood pressure. Now, I know what the values are going to be. And I need to find where they have the same form. So it's going to be like that. Something like this. And now HR dot form. And BP find something like this. And now let's take the max. Do something like this. Sorry for taking so long to do that, but now we have let's do it. Need to remember the syntax. Yeah, just look at this. And assume I managed to do everything properly. Should be able to now do and it actually worked, which is good. Sorry, this is live coding off the top of my head. I'm actually surprised that it works, but that's great. Okay. Pierre is asking, I missed the beginning of the story. Can you share the technical spec, which this is a run number of core, etc.? This is actually running on a cloud machine in AWS. You can see 4 core and 30 gigabyte. I actually don't need a lot of that. We have tested. I'm trying to remember if it was 50 billion or 5 billion timestamp entries on a Raspberry Pi. And the primary limitation there was the hard disk speed, not anything else. So that works quite nicely. What else? Joseph, if I decide to use time series feature as an application log, it seems to be fit as a good decision. What do you mean, Joseph, what do you mean application log? What sort of data are you working with? Sunil, can we create tags on view projection of the documents or a set of documents? This is useful for labeling IoT data from different servers. So yes. So the whole idea with the tags is that you are able to do interesting things here. For example, you can see the tags here. This is a particular file that this belongs to. Here's some other files. The text that you put in the tag is absolutely freeform. The text, the one caveat that I wanted to mention here is that if you put a document ID, like we have done here with the watches, then you're able to load the related document in the query and then do filtering on that. There we go. So now you're able to do stuff like this, because now the tag points to document, the document have this accuracy field. Okay, Matt is asking, building from this example, is it possible to filter the heart rate based on a certain blood pressure? Find the average heart rate when the blood pressure is so and so. And the answer is obviously yes. In fact, let's go here, and let's say that what you can, by the way, you will notice that it's busy doing indexing. We'll explain exactly why in a bit, but you can probably see why. Let's say that what I wanted to ask was based on the number of files that I have. So in these data sets, I think I have, okay, now you can see that I have multiple values for a particular entry. A lot depends on the kind of time series that you generate. In this case, if this was, some value, and then another and another, so heart rate, blood pressure high, blood pressure low, then that would make it very easy to make those kind of determinations. But you can also see that you're able to do that in indexing. And in the indexing time frame, you're able to do something like this to access a particular value. So let's say that we actually had this scenario. So what about your health? From PS and what we needed to do was usual team with group by day or something like that. And then we're able to do this. And then do reduce on a particular time frame. And now here you're able to ask all sorts of interesting questions. Very easily, very cheaply. Romero is asking, if I remove the where clause, so I think you're talking about the query around here, this one. If I remove this, this will execute across all employees, yes. So the whole idea is that first, if you do time series queries like this, the first thing that you do is to select the document that you want, and then you apply the time series operations. On the other hand, you are able to write these sort of queries, and those are based on time series indexes. Notice that here we have something that is very slow. It's very slow because it outputs a single value for every time entry that we have. If you go and look at this, you can see that it outputs a value. But it already has 29 million entries, and it's only going to get larger. That's because it outputs for every entry. Typically, in this case, you do some sort of group by to reduce the amount of data that you care about to the limits of what you actually care for. For example, oh, I care about only an hourly, minute, stuff like that. Depending on the rate of change, that may be able to reduce the data size significantly. Josie is asking, I need to build some behavior application like ELK or paper trails, but for user diet, time series behavior. Yes, if you want to track specific metrics, request durations, CPU utilization, those sort of things, yeah, that's perfect. And you saw the kind of queries that I'm able to run. It's easy and it's fast. Okay. Now that I've dealt with the backlog of questions, let's move on. So indexes, MapReduce, important, and I'm not sure if I emphasize that enough, you can use multi-MapReduce or multiple time series. So you're able to do processing. And this is really important. One second. Okay. Okay. This is really important because it means that you're limited only by what you want to do. One of the complexity of time series that you may have many of them across many documents, or you may have lots of data here. And that allows you to cut down on the load quite significantly. We talked about this. Again, really important. If I'm selecting a range that is beyond 6 hours that I have here, I'm going to transparently fall over to the next ones. And that means that you can set this up and just forget about this. Things will work. Now, here's how we work in a distributed environment. In distributed environment, you can see that we have all sorts of locations that push data to me. And this database doesn't necessarily have to be a single database. Or the whole idea is that I'm able to run it in a multi-master system. And if I have, and it's very common in time series setups, that, oh, I got routine data that is coming in, but here's the CSV files of the data from last month that we didn't put in. So we now need to push that in. Again, going back to whatever the data is immutable or not. Something that is important, if we get ranges that are the same for different servers, we're just going to merge them together. If we get a value that is specifically for that particular time frame from two locations, we're going to arbitrarily choose that based on the highest value. In practice, we found that this doesn't happen very often, but if you have at the exact same millisecond, two values written to two different nodes that are different, RavenDB is going to just pick one of them and move on. And that allows us to accept many occasions. If you remember, I had a webinar showing how you can use RavenDB on the Raspberry Pi and use that as part of an IoT project. That makes a lot of sense because now I'm able to gather the metrics on the Pi and then push them to the cloud. And maybe they go to different time series, maybe they go to the same time series, it doesn't matter for us. Some words about performance. There is the time series benchmark suite, running that on this thing. And you can see the numbers. We're doing pretty well. There is also a timescale DB, which is somewhat faster than us. The whole idea of the time series feature of RavenDB is that we're able to give you great performance for a feature without having to go somewhere else. And that said, I want to show you a few features about query performance. Let's go here. I keep coming back to this because, here we go. So this is the data, this is the data, this is the user. It has 11.7 million data items. Data points. And I want to get that on a, what is the average heart rate that I have over the time frame? Okay. Apparently, by the way, this is real data. This is taken from this Fitbit and others like it. And apparently, there is a significant deviation in the numbers over time, which is strange. Notice, by the way, that I'm doing that on a one-month basis. And let's remove the cache, and let's see. Okay. So 40 milliseconds to process this. That's really, really, that's really fast. Now, let's look at slightly, there we go. No caching, please. No caching, please. Yeah, now we're saying for a period of 1 month, give me the range in days, etc., etc. Now, something that's important to understand, let's look at this range. I move that to do the computation on an hourly basis. Now let's do that on a minute basis. You can see that the time that it took to get the results increased. Part of that is because now we have 40,000 data points that we need to send to the client, and I'm pretty sure it just killed my server. Not kill the server, kill the studio. I'm trying to, apparently there is data here. It looks very interesting. It looks like sort of the wind blowing. And yeah, this I'm just going to give up on that. The key here is that when you query, there is a difference between 1 day and 1 hour and the granularity that you have, mostly because of the amount of entries that we have to send back to you. And the expected utilization of queries like that is that you're not likely going to say, you know what, let's go ahead and give me this thing. If I want that on a daily basis, sure, no problem. 678 buckets. If I want it on an hourly basis, that's going to take a lot more time. And the amount of data that we get back is huge. But so the assumption is that as you increase the range that you query, you decrease the amount of you decrease the granularity in which you go by the data, which makes sense when you think about it. If not, then you can see, by the way, we are processing 9 million records in 2.7 milliseconds. It's not bad, just that and a lot of that is because of the size of the data itself. And I want to touch a little bit on how this works. So when you write the time series data into RavenDB, we divide the data into segments. Segments is 2 kilobytes in size. And then we use something called a Gorilla compression, or Gorilla is a time series compression method from Facebook. It gives us very nice compression rate for predictable values, which is probably the #1 important thing to remember. If you have very predictable values, that's great. If you have very random values that change rapidly every now and then, that makes things harder for us. We have to use more bits to store the value. By the way, if you can reduce the granularity of your data, it sometimes can help a lot. For example, if you only care if you get data from some source that has euro to USD as, I don't know, no idea if this is the right value, but you only care about this level of accuracy, it might make sense to reduce this. But again, at this point, we're talking about almost macro optimizations. What's important with this is that we're not just using Boolean compression. We're also doing LZ compression of the data. So in terms of data density, we're able to squeeze typically 400 to 200 values into a 2 kilobyte segment. Just to give you some idea, a date is 8 bytes, and a value is also 8 bytes. So 400 of them gives you 6 kilobytes. That's at the lowest end. And again, 6 is now 2000. Try to measure, we put 32 kilobyte inside 2 kilobyte. That's the common. We can actually see for highly predictive data, 64 kilobyte into 22 kilobyte. Sorry, 64,000 values. So over half a megabyte into 2 kilobyte range. Now, this is important. This is important because segments are already aggregated. That means that for all of this, we are keeping track of the values. The reason I'm able to run a query like this and give you results effectively instantaneously is that, and again, because I don't have to go over 9 million entries. I have to go over, I don't know, let's see. No, this one, over 18,000 segments. So that provide me with much better capacity of handling that. Queries on ranges that are greater than the segment size are great. I already mentioned, I think, that dates are always in UTC. You have the ability to shift them as you want them, but that's it. Dates are always at millisecond precision. So you can't store nanosecond or stuff like that. And those are all the details that I have. Now it's time for questions. I think that I might have answered all of them already. Okay, we have one. Okay, Fabian. Let's say the time series contain the number of unread emails. How we model an exception while a connection to the mail system? So, for example, let's say that users and read stuff like that, let's see. Now, every some time frame, you're saying, okay, I have another one like this, etc. Now, I need to check it again, and I'm unable to. So I'm going to be able to write something like this and use a tag for that. So the whole idea of tag is that it allows me to give some additional context for this file. Something that is actually quite important, tags are expected to repeat. They technically are absolutely free text, but they're expected to repeat a lot. If you have 10 values, that's great. If you have, again, 10 values for a particular segment, so if they change over time, no one cares. But if you have, if you're using GUIs, which is the worst case scenario for tags, then we're going to suffer in the data density that we have. Okay. Jiresh is asking, is there a way to maintain a position index for each entry in values? How would you deal with missing values on a record? So for example, the BP record, PCT assessment that index 0 was systolic, 1 was diastolic, What is the RavenDB has only one entry? Which one would you be interpreted as? So let's look at the data, the actual API. Commonly, you would use something like this, an array or a collection or something like this. The idea here is that you're going to pass it to me as it is. Now, I'm able to modify this and say, you know what, here is 200, and 5 of them are important. So this is valid. You can increase the size of the number of entries that you have in the values. For blood pressure, for GPS coordinates, it doesn't make sense to say, oh, I have only the systolic pressure. I have only the longitude of where you're at. I mean, previously, 500 years ago, I think the problem was either finding the longitude or the latitude because you didn't have accurate clocks. So then you said, okay, I know where I'm aimed longitude-wise, but not longitude-wise. And I'm not sure which one they were having problem with. But if you need to be able to record this data separately, go ahead and create 2 time series. Remember, you're able to do merges at query time if necessary, or indexing time. But the typical way I would model that would say something that the optional values are always at the end. So this 5 here, these important emails, is only there for appropriate, for the specific entries. Okay, Pierre is asking, how do you handle timestamp in addition to timestamp? If positive, what would be the approach to merge these timestamps together if they overlap? I'm not sure what you mean with regard to timestamp and timestamp. From our perspective, this is a timestamp, and the time span is a particular range of values, so all of those would be in a particular time span. Please give me more information, I will answer that. The release date for 5.0 is somewhere in May. That's the plan. We're going to celebrate 10 years of RavenDB. We hope to push it down. Mircea, if we store GPS coordinates, can we use the data in a spatial index? I have never tried that. I see no reason why you can't. Let's try it. I'm not sure what you would do with that. That's an interesting thing. I have never thought about that. For this, series watches. Let's just kill this. No. Need to remember what the name of the time series was. Location. Okay, so I think I'm missing something. Let's see. So this is really interesting. Yes. So we have this. Seems okay. Maybe I need to add this. That's it. Oh, yeah, it is working. Sorry. You can see that it's working perfectly. If you care about understanding what these are, I think I wrote a good enter here. So to answer the question, Marcia, you can do that. This is it. This means that we're doing things like this. I can probably change the index, say use quotation for a whole bunch of things that don't really matter. Okay. Mo is saying no need to require consistent clocks. Thank you very much. Matt, would every time series be able to be performed enough to store sensor data for, say, 1,000 sensors belong to the same entity recorded at the same time but varying rates between 1 kilohertz and 1 hertz? How might you model that in the database? The typical way I would model that would be something like this. So, assuming that I have different sensors here, then you get the rate here. Now, when you're talking about 1 kilohertz, and that means that you're talking about 1,000 entries per second, right? And times 1,000 of them, it's doable. If I remember correctly, we have something like that. You get to do that. But the modeling is interesting because the question is, what sort of data do you have then? And whatever you need, exact correlation between those different sensors. So if you have, again, systolic, non-systolic pressure and blood pressure, you want it to be a single time series, not multiple time series. Giresh, could you give an overview what is available in the free license versus the enterprise licenses? The time series is going to be available on the free licenses. A big feature for Firewall that is going to be available to the enterprise edition is data compression, but I'm going to be talking about in a different webinar. Let's say that I want to generate, and that's in Lucia, let's say I want to generate a heat map of locations. Thought of making a spatial index that grouped by the geohash, 50-meter range in the reduce function. I'm not sure if we can group by a spatial field. That's not specifically for time series, but your issue is that you don't want to get a great spatial field in this case. You want to let's see if I have an easy way of looking at that. You want to be able to do a QH. Okay, so here is what we do. Let's go to this index. I'm going to call additional sources. And at this point, I have geohash, input. What's your problem? It wants bounding blocks. I guess I can give it bounding blocks. Assume that it also wants this. And save. Still doesn't like me. Also need the decode result. You can probably strip this out. I'm operating under somewhat of a time pressure because I don't want to hold you too much. And that's where I'm stopping. Okay, so you need to do something like this, and that will give you what you want. It shouldn't be too complex to do so, but the whole idea is you don't need to call RavenDB spatial context to do it. Will time series be part, so Matt is asking, will time series be part of the standard RavenDB product or will it be an add-on? It's going to be standard part of RavenDB, just like all of the other features here. So attachments, counter, time series, revisions, all of them are available in the baseline product, not just on the enterprise edition. Raul is asking, how would you partition structure price history for about a few thousand articles, each having one price for each of roughly 1,000 stores on a daily basis? A few thousand articles, I assume articles of clothes or stuff like that, not paper articles. So the question here is, well, the easiest way for you to model something like that is you have 1,000 stores, each one of them has a different daily price for a particular product. The easiest way is just to have 1,000 time series on a document, and that's it. Because you're tracking different values that associate with the same thing. So let's go to Northwind. And we have product 77, and let's just do that. And go to Northwind. Now, now, what's the problem? With now this is actually running on my machine. And so it's actually going to have to go to the remote thingy, and that takes a while, but give it a second one. This is running, connecting, doing the usual stuff. At least I hope it does the usual stuff. Anyway, assuming this, okay. Okay, it starts working. Here we go. So you can see here that we have quite a lot of those. Each one of those has some values, and that's the way I would model that. That's the easiest and most obvious way to model something like that. Okay. Sunil, this is not for V4, this is a new feature for 5.0. Pierre, how would you query time series of some work ongoing recorded by one heartbeat timestamp every 10 seconds? The query would return a collection of units of work with the following rule. A unit of work is defined by all the timestamps that are close to each other with intervals of 1 minute. Means that if the work stops for 60 seconds, it's considered to be finished. The next time we start another unit of work. Okay. The easiest way to do that, we just do, okay, let me see if I can find, okay, so the easiest way, if I can say something like, oh, let me find missing minutes. Let me see if I can do that. And so from users will be that's going to return too much data. So about that. That's going to return 500,000 results. Go by 1 minute. And okay, so here are some results. And now I can look at the data and remember that we can use that in remember that we can use that with a function at the server side. Now I can see whatever I have a missing minute somewhere in this time frame. Apparently not so much. That's one way of doing that. The other way of doing that would be to create the appropriate index and then just say, okay, find me gaps between the values that are greater than 1 minute and then generate the appropriate unit of work that you have here. Romero is asking, can you make this query directly from Excel? The answer is yes. The more complex answer is here. All RavenDB queries, you're able to make them from Excel. There is a guide on how we can do this integration. Okay, I think this is it. Thank you very much for being in this webinar. See you in the next one.